exercise, question 1. Let A, matrix A equal to 0, 1, 0, 0. Show that AI plus BA to the power n equal to A to the power n into I plus n an minus 1 BA, where I is the identity matrix of order 2 and small n. It belongs to capital N, means small n is a natural number. We shall prove the result, this result, with the help of principle of mathematical induction. Prove it with the help of principle of mathematical induction. This we have done in detail, many questions on it in your class 11. Let me revise the statement with you. What is the principle of mathematical induction? Can you tell me? Just note down, given a statement, say Pn involving n, where n is a natural number, involving n, where n is a natural number, such that number 1, P1 is true. P1 means if we replace n by 1 throughout, then the statement should be true. And the second step is Pk plus 1 is true whenever Pk. What do you mean by this? That if we let Pk, by replacing n by k, if we let the statement is true, and we can prove that for next value of n, that is for k plus 1, it remains true, then we can conclude that Pn, the statement, is true for all natural numbers n. That is the principle of mathematical induction. Because you have following 2-3 questions based on it, I repeat, first of all, we'll prove the statement for n equal to 1, we'll say P1 is true. Then we'll replace n by k and we'll say Pk is true. Let Pk is true. That we shall let. And if with the help of, algebraically or otherwise, we could prove that for replacing n by k plus 1, the statement remains true, we can conclude the given statement is true for all natural numbers. So now let me see what is the statement to be proved. Now we have to prove A is a real number, AI, B is also a real number, and A is a matrix. AI plus BA to the power n equal to A to the power n times I is identity matrix, plus n A to the power n minus 1 BA, where n is a natural number and A, is a given matrix 0, 1, 0, 0, and already I is a unit matrix of order 2, 1, 0, 0, 1. At appropriate time, we'll use the value of A and I. Now to prove this statement using principle of mathematical induction, as I mentioned, first of all, in the statement as a whole, put n equal to 1. So on the left side, you get AI plus BA to the power 1, that means AI plus B only. On the right side, you get A to the power 1 times I, that is AI, plus 1 into A to the power 1 minus 1, 0, BA. So if you work it out, on the left side, power being 1, it is AI plus BA, and on the right side, A to the power 1 is A, so AI plus 1, A to the power 0 is what? 1. So it will merely be AI plus BA. So both the sides are equal. So we may conclude that the statement is true for n equal to 1 or P1 is true. So the basic step we have done. We call it basic step. Now next is the induction step. Now let the given statement is true for n equal to k, or sometimes we write let Pk is true. Now what will be Pk? Replace in the given statement n by an arbitrary constant k. So it becomes AI plus BA to the power k equal to a to the power k times I. It's the same statement, just replace n by k plus k times a to the power k minus 1 b a. Call it 1. At an appropriate time, I'll refer to 1 and we can make use of this statement as true. So this is your pk is true. This is a true statement we left. And now consider, actually we are in the process of proving, but what is the main step to be proved here? Pk plus 1. So let me first consider the step which will be proved in the process. Now to prove, what is the main thing to be proved? Pk plus 1. By that I mean we want to prove the statement for n equal to p, for n equal to k plus 1, I am calling it pk plus 1. Here I am just making the statement to be proved. So what do you get? Replace n by k plus 1. You get ai plus ba to the power n, instead n you write k plus 1. On the right side a to the power n, so you write k plus 1. A to the power k plus 1 times I plus n. N is k plus 1. N times a to the power n minus 1. So a to the power, instead n you replace k plus 1, so k plus 1 minus 1 will make it k b a. So this is the statement if I replace n by k plus 1 to be proved. And if you look at it carefully, you know, on the left you have ai plus ba to the power k plus 1. And what is the left hand side of pk? ai plus b to the power k. So the statement 1, that is pk, I am letting true. So if you multiply both sides of 1, which we are letting true, by ai plus ba, at least the left hand side of pk plus 1 will get. So multiplying both sides of 1, which happens to be pk step, by ai plus ba again. So already k power is there, and if you multiply by the same expression, shall I directly write ai plus ba to the power k plus 1 on the left side. And on the right side, you merely write ai plus ba times already the expression which is there in pk step. That is a to the power k times I plus k a to the power k minus 1 ba, which was your right hand side of pk step. Now left hand side of pk already we have got. Just multiply the two on the right side and see if we could reduce to the desired result. Start multiplying with ai to both the terms. So ai multiplied by aki, ak into a will make it a to the power k plus 1, and I, which is identity matrix, will make it I square. Then multiplying with ai to the second term, you get k, and a to the power k minus 1, again multiplied by a, one power will be increased, so you'll get k a to the power k, b a is already there, and I will also be there. If this ai or iai put in bracket, you know in the next step any matrix multiplied by identity matrix makes no difference, and will be in a position to replace it by a only. And now start multiplying with ba to the both terms in the bracket. So you get plus b a to the power k as such, and ai, b a k ai, ai again put in bracket so that in the next step I can replace it just by a. And now multiplying with ba to the second term, you get k a to the power k minus 1 as such, b into b makes it b square, and matrix A multiplied with matrix A makes it a square. Just leave it here for a moment and see. You know the results, that ai or ia can be replaced by a only, because it doesn't matter if to a matrix we multiply by an identity matrix of a proper order, and both the matrices being of the same order, so this result will hold good. Now the next is to replace the value of a square here. What do you mean by A square? A into A. And what is the value of A for you? The value of A is 0, 1, 0, 0 multiplied again by 0, 1, 0, 0. You know the matrix multiplication, row to column. So 0 into 0, 0 and 1 into 0, 0. So you get 0 only. Now 0, 1 multiplied to the second column, 0 into 1 is 0, 1 into 0, so you get 0. Now repeat the process with the second row. You get 0 into 0, 0, 0, 0. 0, 0 multiplied by 1, 0 respectively, you get 0. So what do you find? What do you conclude here? That A square in the previous step can be replaced by a 0 matrix. So what will happen? Now replacing these values, let me call this result as second. So replacing A square equal to 0 matrix in second. What do you find? Already on the left, you have AI plus BA to the power K plus 1. That is already there. And now look at the right hand side. So A to the power K plus 1, the first term, I square. You know, again I square being I into I can simply be written as identity matrix I. And in the second term, IA should be replaced by A only. So you get plus K B plus K A to the power K, K A to the power K B A. And what about the third term? In the third term, you already have B A to the power K will remain as such. IA to be replaced by A, so BA. And what about the last term? In the last term, you have plus K A to the power K minus 1, B square, and into a 0 matrix. So this 0 matrix will make entire thing 0, added to the other terms will make no difference. So further I write, on the right side, it is A to the power K plus 1 times I plus, now taking A to the power K BA common in the second and third term. So you will get K plus 1 times A to the power K BA, and the last term, of course, being 0 matrix, added to these will simply vanish, or at most you may write plus 0 matrix. And if you add all of them, that being 0 matrix will have no meaning. Let me write it again. A to the power K plus 1I plus K plus 1 times AK BA, which is nothing but the right hand side of the PK plus 1, which we considered for proof. I encircled it when I say consider PK plus 1 to be proved. So that is the right hand side. So now I can conclude that PK plus 1, that is the statement for n equal to k plus 1, is true whenever we let Pk as true, whenever Pk is true. And we have already proved that P1 is true, and hence using principle of mathematical induction, PMI I am writing in short, using principle of mathematical induction, the given statement is true for all natural number and belong to it. So that is it.